Hello, so my name is Darren Richards. I'm a current final year PhD student in Alex Cresswell's lab at the University of Bath, and my research is focused on functionalising amines at the alpha position to access scaffolds such as azetidines and sulfuryl fluorides. So traditionally in medicinal chemistry, amines, which are nitrogen-containing compounds, react at the nitrogen lone pair. We instead at the Cresswell Group are trying to access reactivity at the atom adjacent to the nitrogen atom, so the carbon. Our chemistry relies on radicals to access the scaffolds which we're trying to achieve. Trying to do that using traditional ground state chemistry requires an insane amount of energy, whereas if we can harness the power of photons, we can access this at room temperature and also increase the selectivity. So I personally use the Asynt PhotoChip reactor here. You can also do photochemistry in batch type reactors, but the issue is with batch reactors is you're limited to the scale. When you use flow chemistry platforms, you can increase the scale, allowing us to scale up certain compounds of interest. And furthermore, with my chemistry in particular, we are constantly trying to outcompete an undesired thermal pathway. If we utilize the PhotoChip, as shown in here, we can have two streams which go into our photoreactor and that they only mix when at sub-ambient temperatures and under irradiation with blue light, helping us to completely avoid the undesired thermal pathway. Glass static mixer is very useful because we are able to bring it down to temperatures below zero. I personally do my chemistry in -20, but we can actually bring this down to -40 degrees if needed. The glass static mixer has a unique way of mixing by the two streams being pre-cooled prior to mixing. This is particularly valuable for my chemistry because if the two streams were to mix outside the photoreactor, we would get an undesired thermal pathway occurring. So there was a really nice turning point within my project where I was trying to make azetidine-based scaffolds, which are four-membered nitrogen-containing heterocycles. And I was initially doing this in traditional batch-type photoreactors. And I remember the yields were very low. We're getting around 10 to 20%. And then as soon as I translated it to the low-temperature continuous flow setup, we were getting yields up to 70 and 80%. So seeing those NMRs come through and seeing the results of that was a very nice surprise. So flow technology has definitely opened my eyes to the plausibility of using photochemistry to industry. Traditionally, batch photochemistry, obviously you're limited to the scale, which often makes people question whether it is applicable to industry and scaling up. However, by utilizing this, I've shown you can scale up these compounds to multiple grams. And I've even had some industrial collaboration who've scaled this up to kilogram scale. So it really goes to show the importance of flow chemistry. And if you can get your system to work on flow chemistry, it's a really nice transition for photochemistry. Any student who is interested in pursuing a career in science, I would obviously really advocate for it. I've had some of my best times of my life since doing my PhD. It gives you a very unique environment where you get to work independently and get to focus on your own project. And you're also surrounded by other like-minded people. So our lab is full of people around a similar age where you get to share ideas, socialize, and have a really nice time and a very engaging atmosphere to carry out the research. Yeah, so I think I'm a pretty good example to represent Bath University and just Bath as a whole. So I actually came here for my undergrad back in 2018. I studied here for 4 years, and I even stayed on now during my PhD for an extra 3.5 years. So I've been in this city now for nearly 8 years of my life, and I think that goes to show how nice Bath is as a city, but also the research institution here. The city of Bath is lovely, really beautiful architecture, and the Department of Chemistry here is amazing. You're surrounded by really great people, and the teaching here is very good.